Hello everyone, welcome to this new live stream where we're creating an entire game in C from scratch. The game is, getting complete, to be honest. We have come a long way from the first line of code that we wrote all the way to where we are now. In fact, let me just check out the lines of code we have written so far. Let me see. Because I think we did write quite a few, actually. A couple thousand, maybe. Well, it was taking a long time, so I don't know what happened. Okay, didn't work. Yeah, okay, there you go. So this is not our code. This is the library used for an image. So this is actually our code. So 3,000 lines, 3.2 thousand lines of actual code, plus like 9 if you add blank lines in the comments. Probably like 4,500, a little bit less. 4,500, 4,300 lines of code. That's pretty decent to write everything on stream. And counting on the image library, we have almost 10,000 lines. You can watch the whole thing, every line of code that we wrote, on my YouTube channel. So if you go to youtube.com/danzaydan, you can watch from the very first episode all the way to where we are now. This is episode 19, so there were 18 episodes up to this point. And you can also download the game for free on itch.io and the source code as well. And someone asked me to add a license to the game, and I wanted to make that as permissive as possible. So it's dual license to the public domain, and like you're granted a right to do whatever you want with it. So there you go. You can download and do whatever you want with it. And when you click download now, you are welcome to give me a tip if you want to, but then you can just click no thanks, and then you can download each episode's source code, all the way from the first episode all the way to where we are now. And where are we, you may ask? Well, let's see. Let me play the game here. Do you hate yourself? What's the reason you're using C? Dude, I love myself. That's the reason I'm using C. C is a very fun language, to be honest. Very simple one. Not many things to consider when reading compared to C++. And we are doing from scratch. And we are very, very performant. We wrote the software render in C from scratch. And it is running like at 4K. Well, I should probably build a optimized build, right? So when I'm building an optimized build, which is what we should do, it's running at a 60 frames per second locked. So we're running way faster than that at 4K. So yeah, and it's also awesome to learn things like that. Okay, so this is the game we have so far. It's a breakout game. It's called Break Arcade Games Out. It's a pretty bad name, I think. If you guys have any name suggestions. I like the sound it makes when moving, yeah. It was pretty hard, but we did manage to get a pretty decent sound mixer that we can change the pitch of the sound as well as the volume pretty easily now, as well as make it stereo, which is pretty cool. So it starts out as a normal breakout game. So yeah, this is the first level, which is just breakout. And then we have breakout with power-ups. So this was the very first idea that people gave on stream and implemented power-ups. Yeah. Okay, I got strong blocks, so now blocks are invincible, and it's over. So then, we made what the game was actually about, which is making old games like Breakout. So this is Spawn playing as if it were Breakout. Okay, that was a big fail. this is pretty cool. Yeah. Okay, strong blocks again. And then we have Tetris, which is the one that we did last time. Let's see. Oh. Okay. Okay, yeah. I had another idea for this game mode, which is to make like the Tetris one. It's a pretty cool idea. Yeah, and if I manage to destroy this guy, now they're going to start the new challenges. Like this guy can drop like R downs, so I have to avoid those at the same time as trying to hit them. Yeah, there you go. Okay, so now I got 2 blocks at once. Okay. Okay, let's see if I can do this. And I have rotating blocks. Oh crap. Yeah, this may be a little bit too hard, I think. But I have another idea for the Tetris one, which is to make several smaller pieces that you only have to hit once. I may add that. I'm not sure I'm gonna add that before, probably in the very end, after you destroy the rotated pieces. So that's one of the to-do things with Tetris. Maybe also change the speed a little bit, because at this point it's pretty impossible to win. Yeah. I don't know, I have to do some balance again. And the Space Invaders one, which is really cool, I think. Yeah. This one's the best. I really like this one. So that's the point where we are now. The plan, just to make you guys aware of the to-do thing. Oh, yeah, that's the idea for the tips. Make smaller shapes that use the neighbor system, so you only have to hit them once. So I'm going to note that on the game. Like, I'm gonna note that as another idea. We did the Tetris one. In Tetris, make smaller shapes, the neighbor system, so you only have to destroy 1 block. Okay, now the plan is today we should redo the collision, because there are a few weird cases that the collision is not 100%. And we definitely want to fix that. I mean, it's kind of hard to reproduce. That's the biggest problem. It's kind of hard to reproduce that bug. But we are going to take a special care on the collision today. And hopefully by the end we'll have a more robust system. We should also improve the feel a little bit, like screen shake, menu stuff, transition, that could be cool. Review the size of the player wall collision, so in cases like this one, we increase our size. I'm moving my mouse to the left, so I should also move him to the left, the square. Then add a sound, and then maybe we can increase the text. Maybe we're gonna leave this for the next stream. It's maybe gonna be too much. So at this point, when we finish this guy, we will be left maybe with more gameplay exploration. I'm not sure though, because we did a lot of gameplay today. Not today, I mean, already. And I don't want this to be a super long stream. We're going to spend hours and hours of gameplay, because you guys got the idea, right? We could go all crazy on all sorts of weird game modes and get more out of the game, which is probably what I should do. But since I'm only programming this game on a stream, Not sure this would be the best call to spend like hours and hours and hours playing around with the gameplay. So I think I'm going just to finish these 5 levels, improve them, and then we could do the polish pass, which is make like the full screen launch prettier. Well, let's see, yeah, on the non-developer build. More optimizations maybe. Not sure if we're gonna need. We're running pretty smoothly. Make an async odd reader so we can get the data size down. Right now our data folder is like 50. It's like 25 megabytes. The music alone is 14. The sound effects are like 11. So if we make like an OGG Vorbis reader or use one, we're probably gonna use a library for that. We can get that data folder way down the side. Save and quit. I'm not sure though if we're gonna need that because we are already saving every time we need to. Make the cooker to cook the assets. That will go along with the OGG reader. That could be pretty nice, and that's a cool thing to stream. That'll be a nice challenge. The asset cooker, like asset cooker. Make return the player's mouse. Yeah, and some small things. Yeah, and the game and test is at lower frame rates. Yeah, and after we do this, we should be able to launch the game. And I'm gonna share it with you guys because I'm pretty sure that I'm going to release this game on Steam as well. So that'll be a cool thing to do. I can't implement the Steam API on a live stream, unfortunately, but I can show my API abstraction layer, I suppose. So I'm gonna do that, and then we can release. Yeah, that'll be it. Like online subsystem, and then release. And we're gonna leave these guys for like next games. Okay, these other ideas that we had. So that's the plan. So let's start now. We're gonna break the game pretty badly today with a collision, but I think it'll be worth it because that's one important thing that I should say is that when we start the collision day 2, as you can see, even the name of the video is like gameplay epic collision failure and epic collision success. Well, as we can see now from the future, it wasn't such an epic success because we are having to review the collision system. But the thing is, when we first wrote the collision system, we weren't 100% aware about where to fit it perfectly. So we didn't want to spend like a lot of time perfecting it. As of now, since we are getting the polishing done, getting the game down to its release state, we can focus a little bit more on making the collision perfect. So now we can go back with a way better, condition, if I should say, to go ahead and review the collision system. Okay, so we ended up using a sweep, which is like we have the ball position and the desired ball position, and we have like blocks, and we can test whether or not the ball collided with like this guy, and if it did, we can move the ball back to where it should be, like at this point, and then destroy the block, and then change the ball direction. So that's the basic thing. We are doing this. Now the problem is, there are some tricky situations, like if you have like 3 blocks like this, it would be cool for you guys to see the problems on stream today. But last stream you could really see the collision problem, like a couple times. Even it was like almost looked like the ball went through one block, which has to do with the way we are. Oops, I looked at the comments on the ball. Which has to do with the way we are. The way we are processing the collision, right? So that's one of the biggest things that we have to change today. Okay. The idea is, let's say we have the ball. Okay. And let's say we have a desired P based on the ball DP. So the ball wants to go here. Okay? So the main thing, starting out, just like I said now, the thing is, the ball is the main thing. It's not the blocks. So right now our collision, let's see, our collision is being made, let's see, on the blocks, and then we iterate through all the balls. I'm going to do the other way around. I'm going to do for each ball, I'm going to iterate through all the blocks. And just note on performance, we are running like in 4K, let's say it's something like this, right? No, it's 20, 38, 60? 38, I don't know the size of a 4K display, but it's over 8 million pixels. So we are running a few things like our render, and it's not like trivial things. We are also doing like draw, well, that was our font rendering. In our, well, we are drawing with subpixel accuracy, some things. We're drawing bitmaps, so we're doing like texture fetching and sampling for every pixel of the 8 million ones. Well, not everyone have textures. And we're also doing like, well, we can delete this guy. Oh, this was one of the ideas that we could make that faster. And we're doing like the rotated guys every frame as well. So we don't really care about performance at this point. I mean, for this thing, because we're iterating like through, I don't know, 300 blocks a couple times for each ball. So going back, so for each ball, let's go through all the blocks and see if they collide. If some of them, if like one collides, I'm going to calculate the null position. And this one's going to be the old position now. See, I'll make this line. Yeah. Then I can destroy this block. And then I'm going to iterate through all the blocks again. Like we implemented that last time. But this is the thing. Okay? And yeah. Yes, exactly. So this is the collision point. And this is how much we should advance based on that collision point. Okay? So let's do a few things. We simulate the block for the level. This might change like the block position. So I'm going to change this before we do the ball update. So first thing, we're going to like update the block position. Okay? Then the balls. And then right here I can do the like ball block collision. Okay? Probably think the first thing we should do is the simulate level though. Let's just go to the level. Let's see what we do here. Yeah, we update the position. Yeah, so we simulate the level, then we update the blocks, then we update the balls, and do the player collision with the ball and the player collision. Well, where's the player? Probably update the player first. Yeah, we are doing the play first. The player we're doing, yeah, up here. It's not dependent on the game mode. The game mode. Okay, so after we do the ball block collision, we can start doing the rendering because everything is done, I suppose. Everything simulation-wise. So we're going to go through all the blocks again. If we collided, now I'm going to think about this now. Well, oh, so we're doing that again. Oh no, this is like, oh yeah. Okay, so this is the actual collision. Yeah, this is the actual collision that we're gonna change. Okay, so this is what we're gonna work on now, and then we have the force field rendering, and then we draw the blocks. Let's do like draw blocks, and then we update the power blocks. Probably also update the power blocks. Well, it doesn't even matter. Yeah. And then we render the particles and the balls and the walls and the HUD. Okay, this looks okay. So now we remove the collision. So now we should have no collision whatsoever with the blocks. Let's see. we don't. Okay, so the challenge is to add collision back in a way that it's way more robust. So, okay, pretty cool. Let me just pull this up here so we can look for reference. So for every ball, I'm going to go through every block. Oh, if it's not the first ball movement, right? I have to do that. So I'm going to go through every block and see if there's life in the block. Okay. And yeah, we do have this do ball block collision, and let me show you what this is. We take a ball in a block, and then we do the sweep based on the ball desired P and the ball P. Okay, so these are our main variables, right? So, and the DP and the half size. Okay, yeah. We got the collision point. Yeah. Okay, and then returns true if I collided, if I actually destroy the block, honestly. Yeah. If I destroy the block. Well, this shouldn't be if I destroy the block, but just collided. So even if we collided with a strong block, we should return true, like at this point. Yeah. And then return false at this point. But I'm not sure we should return also, because for instance, if we return when we, yeah, this means that we're gonna change just one side, I suppose. Yeah, I can't return. I'm actually going to do like a result equals false, because if we should collide the ball in two directions, we should probably change both directions, I think. That's one of the problems the collision is, one of the reasons the collision is feeling a little bit unpredictable, which is like totally not the way it should feel, right? Okay. Okay, now for every ball, I'm already checking if it's active, right? Yes. Okay. And then I'm gonna do the collision. Okay, and if we collided, test all the blocks again. And then we have to update the ball properly here. So we're going to review, yeah, the desired P. We're also going to change the P. But the idea is we go back through all the blocks, right? Blocks equals blocks minus 1. Then we break. Well, I don't need to break, but I'm going to break anyways. Well, no, this is wrong, man. That's really stupid. We are breaking out of the loop. Oh, because this is like the ball loop. Okay, so yeah. At this point, we don't need to break. All we need to do is to set the ball back to the first ball. And then we can do all the tests again, because now it may have passed through this ball, but now we want to check it again, because the position has changed. Okay? So this is a new basic thing for the ball block collision. But now let's review what happens when we collide. Okay? So when we do collide, we increase the ball size. We set the DP to the lerp on the player DPY. Okay, so this is the new, this is this position, right? No, this is the P. Yeah, from the P to the DP to the desired P, we have the collision point, which is TY. So at this point we collided. Probably also set that on the X. For some reason I'm not setting that on the X, the target X. Is that correct? Let's see. Well, before we go around and mess with this thing, we should have basic collision back. So then we can go ahead and make that a little bit more robust. Let's see. Yeah, we do have. This is pretty much what we had. pretty much what we had at the other point, okay? But we can do a better job. So this is the thing that we wanted to do. We want to put the ball here, and then continue the collision, testing like for other frames, this new position. So we have to calculate that. So we could also do like more robust things. And you know, this may be the problem, I'm thinking. I think this is the problem. Yeah. You know what? We're going to change the collision a little bit more. Let's say we have two blocks like this. And the ball is going, well, since we are updating the blocks like bottom up, let's do like the ball here. So the ball is here, and it's a super fast ball. It wants to get here. Yeah. Yes, exactly. In this case, I think it's going to work. In this case, we're going to simulate this block, and we're going to say, okay, oh, it collides. So we should move the ball here. And if we do what we said we were going to do, we're going to move that up, so it's going to collide with this block, so it's going to move down. So when we finish this frame, we would have moved, we would have ended up here, moving down, having destroyed these two blocks. It's really weird. In the correct simulation, we should end up like here, or maybe if you're fast, you should end up like here, right? Because we ricocheted off and moved up already, and destroying just one block. So we can't just test, we can't just set, where is that? We can't, oh, here it is. We can't just set the new position here. Because all this means that we collided with this block, but it doesn't mean that we collided, because it doesn't mean that this is the first block we collided with. Okay? So, actually like the ball, update ball. Here, when we set the P to the ball P, we're going to do this here, the very end of the update ball thing. But instead of just setting that to the desired P, we should probably do a lerp, right? Probably do like this lerp here. The ball P is going to be wherever it started. Well, if we didn't collide, it should be 1. So, yeah, it should be 1 if we didn't collide. But if we collided, it should be whatever the value that we collided with. So, I'm going to call this like min t. So, it's the smallest t, right? And we're going to start with the min t of 1. So, the smallest collision is like the end of where we want to go. Okay, it's the first step. Now, then we're going to check the ball collision, passing the ball, the block, and the min t. We also pass a block, right? Maybe I should inline this again. Yeah, I think I'm going to inline this. Well, no, not yet. Let's pass now the, or we do have the ball. So I'm gonna save like, actually I do, yeah, block, like block, hit block. Okay, and then we're gonna pass the hit block. Okay, so now what we do is whenever we try to collide, we receive, should be a pointer, right? A pointer to the min t here. The min t. Actually, this should be a pointer to a pointer because we want to change the pointer. And the hit block. Okay. Okay. Now, we calculate the difference between the desired P and the ball P. Then we get the collision point, in this case, which is like whether or not we should test with the upside or the downside based on the dP. And then we get the Ty. So if the Ty is greater than 0 and less than the min T, yep. Then instead of doing this, Well, yeah, instead of doing this, I'm gonna if zero this whole thing out. Instead of doing this, I'm gonna set the min t, the ty. Oh, actually, oh, this is wrong. Actually, this is just to test. This is to test the x position, because the x position here have to see if we are in the range, right? So this is the test. So we do have to do this. So yeah. So yeah, this is the actual collision. So now we increase the ball size, we set the desired p, the speed multiplier if we need to. Yeah. Okay. So at this point, we're going to set the min t and set the hit block to the block. Actually, we should have a min y and min x. Because like here we moved the x. Yeah, and now we also changed our min y. Yeah, so min xt, min tx, min ty. Okay, I like this. I like this. Min tx and min ty. And this is going to be the target x. Well, I can call that tx. I don't know why I didn't call that tx. Tx. Okay. So the tx and let's set the hit block to the block. And let's see. We call it the block. And maybe now we are safe to return. Yeah, I think this is correct. Then here we're going to return false. Oh, we're going to return the result still. Now same thing here, we're going to if zero that out. And if this guy, and then I'm going to do the same thing. Okay, it's going to be pretty good, I think. Now we have to take the min x and or the min ty and the min tx. Same thing here. Min tx and the min ty. Okay, let's see. And this should be the min ty. And this should be the min. Yeah. Min tx. And then we call that ty. Okay. Okay, nice. Let's see. Min ty undeclared identifier. Yep. Min t. Okay. So, oh, so actually this is wrong. This, yeah, I don't know what I was thinking. We only need one, which is the min t. Yeah, yeah, because we're actually going to lerp with that value. We're not going to get that value individually, I think. Yeah, yeah, because the t, yeah, it's not. This is actually right. This is actually the target, or maybe I'm going to call that at y, yeah, which is like, what's the value of y in the point where we are at, see? So now we're not going to set that to the y, we're going to set that to the tx. Now I'm going to set the x, we're going to set here the y. Yep. Yeah, I think this is what we want in the first place. Okay. Now we have to pass the correct things here. Yeah. Okay. Cannot convert v3 to v2. So yeah, the loop's going to be the whole thing. Oh, it's gonna be way better, I think. Do we have alert v2? I don't think we do. Matrix random v2I v2. Okay, so alert v2 is going to return this guy as v2s, and then we can okay, if you guys have any questions, be sure to drop them on the chat, and I'll try to answer it. Okay, let's see. We compiled, but I do wanna, well, we haven't finished writing the code yet. Okay, so, well, we set the min t to this guy, to the hit block. Okay, so, yeah, this is what we want to change. If we collided with a block, actually, no, this is wrong. This is wrong. Now we're not going to do anything if we collided. Not going to do anything. Yeah, this is going to be perfect, I think. Not going to do anything if we collided. Okay. Yep. Because actually we do know if we collided, right? Which is if we have a valid hit block. Okay. And the thing is, when we finish looping here, I can do it. You can just set the absolute desired to the case where we don't try collisions. Okay, now let me see if I hit with the wall. I set the desired to p. I should also change the p. Yeah, so yeah, I'm gonna have to review this also. But this is the basic idea. If we finish and we hit a block, yeah, we can do this in the else case. If we hit a block, what are we gonna do? First of all, we are going to destroy the block at this point. So yeah, we're going to do actually this whole thing, like hit a block. Okay, nice. I'm going to increase the ball size, and well, this is what we have to rethink. We're going to change the ball speed multiplier, and we're going to check if the ball has a strong blocks. Then in this case is the hit block. And test if it has a life. Then we destroy the block. Okay. Now we're going to set the P, which is the no starting point. Yeah, the P is going to be the result of the alert. Okay. Yeah. And then, let's see, the P, and this would be the min T. We can do alert v2. Okay. And well, we have to know the direction though, because here we copied Yeah, copy this guy. In this case, let's see what we do. We increase the ball size, change the speed multiplier, do the lerp, and yeah, we have to test the comet, things like that. So I'm going to do like collision happened with y, which is a bad name. Yeah, so if collision happened with y, else, this is what we're going to do, change the ball dpx. So if we hit the x, all I'm going to do is change the x. If we hit a y, we're going to test this whole thing. Ball dpy, change the comment, then reverse the ball dpy, or else we're going to do nothing. Process ball, okay. I think this is going to look, this is like remove the block life. This is going to be way better, I think. Then we can probably, yeah, we could probably inline that as well. One step at a time. Okay, so at this point, we can set the ball P to the new guy, just here. Okay, and then we can do this again. Yeah, we can move the ball again. And then we should probably have to test the whole thing. Let's see, play collision with ball, because it could hit a wall. And yeah, the end of the arena is not really light. And the update sound. So this we don't want to do twice. But you know what? This I think I'm gonna make this thing down where we're gonna do the ball, the render ball, because this is more like static thing, not gameplay related. So it gets like the newest value. So when we hit a block, this is what we'll do. Okay, yeah, this looks a little bit better. So I think we're gonna have to run this whole loop. But instead of changing the DT, I'm also going to change. I'm going to do like something like ball DT. Let's say ball amount, moved amount. So it started out as 0, moving amount, and then the DT, so I'm going to multiply that by 1 minus the ball movement amount. Okay. Oh, you know what? I'm gonna drop this guy in here. I'm gonna do like a while ball movement amount is less than 1. I'm gonna run this whole thing. This is gonna be pretty good, I think. So yeah, so we start updating the ball, and we want to move 1 from 0 to 1. So while we still haven't moved 1, we're going to set the desired P to be the P1 minus whatever, right? How much we have left in our movements. Okay, then we do the player ball collision with player, with the wall, with the other wall. We check the end of the arena. We do the ball and the block collision. Now, in this case, we're going to set the P to this new guy, and we updated whatever we needed. I think we can do like this up here. So we change the ball, the block things. We change the ball size. We change the ball speed, which is going to be pretty cool. We change the collision, yeah, depending on whether or not it happened with Y, which I'm going to have to know down here. So do collision player, let's see, collision happened with Y, and if it happened with Y, collision happened with y equals 3, if it happened with y. Okay, so no need to do this. Need to do this. I think we are going to go to a good shape now. This is the hit block. Yeah. Okay, update sound. Set that to true. We don't update sound if we collide with the top arena and the ball is not active. Oh, because, yeah. Well, but if truth be told, if the ball's not active anymore, it's not even going to run this guy. So this is going to be pretty cool. Yeah. Okay, I like that. We do have to be careful though, because this is going to break a lot of things. But this is going to be a pretty robust collision system, I think, that we can utilize on other games. And this knowledge also. So, I'm going to put that comment here. Just, I don't know. Okay, now we set the ball P, which is the new starting position. Setting the new starting position to the ball P min T. Okay. And yeah, collision happened with Y. Did we yeah. Okay. And then we should run through this while and check again. Okay. I like this. Let me put a debug breakpoint whenever we hit a block. So game line 437. So yeah. Got a problem with the sound. I guess was that sound. It's weird. Let's see, which sound are we trying to play? Oh, well, it's probably to the debug mode again. Let's see. I'm turning your volume down because that was a very unpleasant noise. Yeah. Okay, so sound. It is a lose life sound. That's weird. Let's put a breakpoint in the play sound. So yeah, we play all the initial sounds. There are a ton of initial sounds. Okay, we are supposed to play the start game sound. Looks good. The lose life? Who's trying to lose a life? Lose life. Ball reached end of the arena. So probably this calculation is wrong. Moved amount is 0, so it's going to be dt times 1 minus 0. Yeah. Why is dt 0? Oh, yeah, I don't know. So the ball P is 0.45. Our ball desired P is 0 minus 50. I don't know if this right. I assume the ball was supposed to be going down. What's the ball dp? It's minus 50. So yeah. Move this breakpoint. Okay. Trying to move the ball, which is the first ball, right? 2D00, yeah, 2D00. So dt is 0.016, ball moved is 0. So this guy should be, yeah, this is correct. Our ball dp is minus 50. Yeah, this is correct. We're supposed to be going down. This is 40. Oh, okay, positive 40. So we're just a little bit down. This looks pretty correct now. We don't collide with anything that we care, or at the end of the arena. Probably, yeah. Yeah, it's the first ball movement. Okay, so this looks correct. Let me remove that breakpoint, but let me just put these variables, let's see the game, inside the if. These ones, because we only care about that. It's the first ball movement, then we do the collision. Yeah. This is a more common, robust collision loop, just for your information. Yeah. Well, anyways, I'm going to put a breakpoint also in the, oops, did I close something. In the lose a life, where's that? Here. Ball desired P is minus 50. Okay, let's see what's going on. Ball moved amount is, oh! Okay. Huh. Yeah. This is very wrong. We're not setting the movement amount. So yeah, if we didn't do the first ball movement, we're gonna set the movement amount. What is it called again? Ball moved amount. Well, okay, so set the ball movement amount to 1. So we just forgot to, well, I just forgot to finish to write. Okay, so, and in this case where we do a min, we can pretty much just set the movement. Yeah, and the min t is going to be the movement. Well, we can stop operating on the min t and start operating on the movement amount. I think that'll be better. So let's call them ball movement left 1. And while it's greater than 0, yeah, ball movement left. I will still have movement. And then instead of passing the min t, we're gonna pass the ball movement left. Yeah, I'm really liking this system. We pass the ball movement left. And then I need to set. Oh, yeah, no need to. If we didn't collide with anything, we should probably set that to 0. Let's see. If we didn't collide with a block, the movement should be 0. Yeah, because this means we did the full movement. Ball movement left. Okay, make our bets, everyone. Let's see if we get something. So I'm still going to break Now let's break on these two cases. Okay, so we didn't crash, which is a progress, but we didn't move the ball either. We are probably going through this case, because there's no ball first movement. So we just set the ball movement to movement left to 0, and the ball P to the ball desired P. Right? Let's do ball again. Let's see. I never use balls again. Just in the render ball. And we updated their sound. Yeah, this is wrong. We should really be now the P. Ball sound multiplier with the ball P. And you know what? I think now the ball deep, well, we use it here, but we could have eliminated that also. Oh, yeah. Ball DP, DP, trail, DP, trail, flags, DP, P. So that wasn't very consistent, but now it's correct. Comment sound, draw ball. Huh. Oh, okay. We changed the movement to operate from 1 to 0, and we forgot to change this guy. Okay. Let's see. I am starting to get confident that this will work. Okay. Now this is a very problematic collision. Let us analyze, and let's assume to know what we want. Then we can improve. Now, in fact, we should probably collide with 2 blocks, and then I think this is going to return just this block, because yeah, it should return this block. Yeah, because let's see. Let's imagine this line. This one we collide when we are here, and this one we collide when we are. Oh, is that correct? No, I think we're colliding with them at the same time. So we probably expect it to get like a random block, which is not. Which will be this one in this case. We probably hit them both, I suppose. Collided with them both. I'm not sure. Yeah, yeah. So the most correct thing that we want here to destroy them both, but let's see just what happens. So we collided with a block. Oh, we already computed that. So you know what? I'm going to make a temporary breakpoint. Let's see. Inside here. Just so we can see the collision before it actually finishes. So we can see the 2 collisions. But now, just 1 collision will happen. Anyways, so the collision happened with Y is true, and the hit blocks the block, and the movement. That is -18. This is wrong. Should be between 1 and 0. 0, yeah. -18. MT. Yeah, this is wrong. It should be the TY. Okay. Okay. So we're testing the TY and the TX just to see if it's in the X range. But the collision actually, in this case, is happening with the Y. And in this case, happening with the X. Okay, so that was just a small typo. Let's go back to debugging. Okay, now I probably, I don't know, probably just, yeah, just 1 collision. So Movement left. Ah, now we have 0.18, which looks perfect. Hit block, collision happened with Y is true. Okay, so now we're going to keep moving. And, well, we collided with 2 of them, I suppose. So I guess it did collide with the other one. Yeah, well. Yeah, I'm not going to complain, I suppose. And you know what? I should probably set the collision happened with Y to true, and here I should probably reset that. Because if there's a X collision that happened before the Y collision, they should take precedence. So, yeah. Okay, now we should probably just have 1 collision. And we do have more than 1. Let's see if we have 3. And we do have because now everyone's going to be true. Okay, so not a problem. Now, the ball movement left is 0.85. So we got a collision right in the beginning of that frame's movement, right? Because we are pretty close at this point already. Okay? So what we want to do is, well, let's see if we're going to destroy the block, and we will. So we destroy the block. We increase the ball size, and we're probably going to make it faster. And did the collision happen with Y? Yeah. So are we going up? Yeah. Do we have a comment? No. So we're just going to reset and reverse the ball P. Process the ball with DP down, whatever. Okay. Now this is the tricky part. So we started out with minus 18 in X. I'm gonna well, minus 18 point. Yeah, I think I'm gonna write these numbers here. Just so we know, like this is the ball P, and this is the desired P. This is inside. This is inside the cube, the block. So we are going up, right? So X is getting greater. Okay. Now we should set that to 0.85. Yeah. So this is the new ball P. Let's see, it should be between 19.2 and this looks great, I think. And now the ball movement left, well, we still have movement. Okay, so we should probably move the ball again. So that's what we're going to do now. We do have movement left. So now the desired P should be the ball P and the ball DP changed, right? So now we should be going down, which is correct. And the ball DT times the movement left. This is wrong. This is wrong. Yeah. If we moved, yeah, this is wrong. Like, if we what we're testing here, I think what we're testing is correct, which is we're testing how much. Well, let me draw that to make it a little bit easier. Let's see, we have the ball and the block and the ball here. So let's say, well, let's make that a little more evident. Okay, so if we moved up to 85, our movement left is just 1 minus 85. So yeah. So if we did collide, in this case, the movement left is going to be 1 minus ball movement left. Yeah, okay. Okay. Let's try that again. Okay. So we collide with the block. We, do whatever we need to do. Change the ball position. Okay, now the ball movement left 0.44. What this actually means is that we moved. This should be the min t. So I'm going to rename this guy to min t. We started out as 1, so the min t should be the ball movement left, correct? Should start out as 1. Where's the new drawing? So we start out as min t is 1. Min t and the movement left. They are both 1 at this point. Now we collide here. Yeah, this is perfect. We collide here, so the min t is going to be, I don't know, 0.85. The movement left should be 1 minus 85. So yeah, we start out like this. Then whenever we do the ball movement left, we do now the min t. And that's it. So this is going to be the min t. Oops. The movement left is 1 minus min t. Okay, now let's see. Perfect. Let's see, let me put the breakpoint down here. Okay, now the min t is 0.55, which means that we managed to move up to 0.55. So yeah, we have like the ball. Yeah, the ball P moved up a little bit. Now this guy should be 45, and it is. That's the movement left we have. And we're going to move that this amount. So the desired P. So now we're going down again. So our y is less than the way it is now, the desired y. Okay, and then we try to do all collisions again, and then we're gonna have to do them all, I suppose. But now it shouldn't collide with anyone, and it doesn't. So in this case, we set the ball movement left to 0, so we move the whole thing, and just we set. Okay, this is. I really like it. Let's see if it works. We debugged apparently and understood the problem. This is gonna be really cool. Let's see. Okay, this looks perfect. We probably have to fix that in that case where we collide with 2 blocks. Yeah, see, probably. I don't know. This already feels a lot more predictable, I think. Well, okay. So it's not working in that case. I'm gonna see my notes, because I did take some notes. Possible red flags. Assert that the DP is based on the final P. Yeah, the DP is based on final P. The ball P, the beginning of the sweep, should be updated when the ball desired P changes. We're not doing that for everyone. So let's do this. This was the wall collision thing. In this case, see, we update the ball desired P. This is wrong. We should really let me think. If we collide with the wall, we're going to do the same thing. We want to change the ball P, then we calculate the desired P. But you know what? I don't know. But let's see the other red flag. So setting the other axis when collision hits, we change this whole thing. Now we're setting the whole thing. So testing both directions for 2. The idea behind this testing both directions, because here in the collision, we just see whether or not we're going up or down. So no need to test both directions. Collision only when inside. This is interesting. Should we collide when we are right on the edge? And I suppose it should be. So I suppose this is less than or equal to this guy as well. Return false when any collision. Avoid double. Okay, so we assumed we would need to return false to return, I suppose, in this case, to avoid double, but we didn't get double collision. Yeah, it wasn't the problem. The problem was like no collision. So let's analyze that a little bit more. Yeah, see, I think the problem was 2 per frame. Yeah, so this looks correct. Well, it doesn't even matter. It doesn't even matter. But I suppose this is a little bit more correct. And you have to do the wall thing. But let's fix this immediate problem, which is the hit block. I think the problem was when we are already inside the block, the sweep wouldn't work. Yeah, when we are, see, because if we sweep from this, well, you know what? I'm gonna do a crazy thing. But let's see. When we spawn the blocks, let's spawn huge blocks. Just so we have like a collision happening. Well, that wasn't that huge, was it? Which is the size? Oh, this is the size, I suppose. That was the spacing. Well, let's make the blocks even bigger. Yeah, but we want the blocks to actually collide the players, so 15. Let's see. See, this is the problem. We changed a collision. Well, we're not sure because this is not a block collision, but the idea is the same. If you are sweeping from inside the block, we should destroy it. Yeah. So we have to make sure that this works. And then probably have to make no, I think that's the only problem. Sweeping from inside the blocks. Okay, so when we do, let me go back to the level. When we do the ball block collision, here, the sweep, this is weird, because I believe the sweep should, oh, the sweep's getting the the limit. You know what? If we tested both sweeps and didn't collide, you know, this is another thing we could have done. Okay, so yeah, see, doing things after you've done them for the first time in one project makes it really more clear the advantages. So the idea is, if we are colliding, we take like the ball and the block. I don't know what does ABB versus ABB take. We take a P1, so ball, desired P, half size of ball, half size, block P, and the block half size. If we are colliding, the ball is already inside the block. I'm going to do that, see, this is where I think we should probably collapse the loops. But if we do the block collision, let me move this. If you collided with this block, so I'm going to do like, I am going to do if you collided with this block, well, if we didn't collide with this block, and we did the ABB test and failed, which means that we are inside the block, I'm going to just fail the collision. Like, I'm gonna set the min t to 0, which means that we don't move at all, right? And then we set the collision happening y would be, and we can probably break the loop here. Yeah, because if we are inside a block, it doesn't matter which block we collide, we are inside it anyway. Actually, if this is 0, yeah, we're going to try it. Yeah, this is perfect. Now, set the min t to 0, which means that we got stuck on this iteration. And we also have to change all the collision happening in y. I'm going to set that. It's kind of a hack, but it's a hack that we could have done that before. And probably saved us a lot of headache, but it wouldn't be as robust as it's going to be now. But the idea is, it is a hack, right? But if the length of our y, I can do like sweep path. I'm gonna do like the length squared. If the length squared of our ball desired P with the ball P, I'm gonna do the desired P first. Second. This will be the sweep path. The collision will happen with the y if our sweep, well, no, not the length. The thing is, if it I'm gonna just do the minus, yeah. I meant the right thing. The sweep path is the sub v2 of them. So in the collision will happen with the y if the absolute of the sweep path y is greater than the absolute of the sweep path x. Okay. Yeah. In this case, it'll mean c. In this case, I'll do the y. It's not 100%. This is like maybe even be a really bad solution. Yeah, you know what? I'm not going to change it at all. So I'm going to say like collision, let's say ball update axis, set that to -1, which means none, basically. So it's going to be ball update axis be -1, 0 for y. Oh, let's see, 0 for x, 1 for y. Level, so ball, what's that? Update axis. In this case, it's y, so 1. No, this is x. X will be 0. And this will be 1. Nice. And in this case, I'm going to change the name. Okay. Okay. Illegal for type void. Yeah. So we wanted to know whether or not it collides. So return true. I think I'm going to. Yeah, I'm not going to. Until it's 100%, I'm not going to delete the code. So return true, and this will return false. Okay, can't convert F32 to V32. Which one? I think the ball have size maybe B2. Yeah, so if we hit a block, we're going to assert the ball update axis is not -1. Well, this is wrong. Yeah, because that's the thing we are changing here, right? So ball update axis -1. Hit block. It's gonna be block. Yeah. Yep. Okay, so if the ball update axis is 0, let's do 1. We do the y. Else, if it's 0, we do the x. And if it's not, we don't do anything. That's it. Okay. This is exactly what we wanted. Now all we have to do is make sure that we have a functional collision system. Right? I mean, that's just what we want in the first place. Let's see. Okay, nice. I like it. I like it. Okay, until I get the ball to the breakout, yeah. This looks perfect. Even that one, I think that was the correct one. It was too fast for me to completely understand. But I think that was correct. Oh, that's the ball. Okay, so now I can say, I mean, we have to test more, right? But in theory, the theory behind our collision system is now very robust. I can say that. Because it's doing like sweeps and it's doing like, well, we still have to fix the wall thing, right? We're gonna fix the wall thing now. Let's fix the wall thing. The wall thing is the thing that, let's see, in the, well, here, whenever we collide with these guys, I probably don't have to worry about the player in the ceiling, because it's not going to hit a block and a player in the same frame, nor the ceiling and, well, the ceiling, it could happen. You know what, let's play the pawn. Let's try to get the ball behind the pawn. It's going to take more effort than that. Dude, it's crazy. I really like the pawn level. I really do. Yeah, see? So we may hit the ceiling and the other guy. So we have to check out these three guys, right? The ceiling, yeah, these three guys. So, and actually in these cases, I can pretty much just set the ball movement left to 0, which is not 100% accurate, but it'll work now. I'm gonna comment like a hack. Maybe we can change that later on, but well, oh well. Yeah, if we hit the end of the arena, we're not going to move anymore. If first one movement or one movement left is less than okay, so in this case we're going to ignore the block collision. In this, which is the player and the bot. Perfect. Now in these cases, we do have to know how much we moved. I mean, we could also just set that to 0. This would probably means that we have probably less movement on the frame we hit the walls, but I don't really think that'll be a problem. Yeah, see, that wasn't noticeable at all, and that collision was awesome. Yeah, I don't really notice that at all. So I think I'm gonna leave it like this, and yeah, it's marked as hack, so we can go back and improve. Because that's the thing, we don't want to make the perfect collision system at all. What we do want to do is a better collision system than we have last stream, and that's life, man. Just make 1% better every day, then it'll be 100% better after 100 days. So I let me test a little bit more, but I'm pretty confident that our collision is perfect now. And just because I said the word perfect, it's gonna have a horrible problem. Yeah. See, I think that case the ball was already inside because it took a while for the guy to appear. That was pretty cool. But visually that was fine, and in terms of correctness it was 100%. So I'm not going to complain. Okay. Yeah, that was pretty well done too. And I'm probably gonna have to watch some of these in slow motion. Or I could play the game in slow motion, but it would be kind of boring. So I think I'm just going to play a little bit, and then I'm going to record and test collision. Yeah, see? Let me understand what happened there. Just to make sure. Because that was a bit weird. That was a pretty nice one though. I'm going to stop and start the recording. Okay, just so we can analyze the very end of that thing. Let me go to the recordings. Okay. Let's see. Hello everyone, welcome to this new live stream. Perfect now. In terms of correctness, it was 100%, so I'm not going to complain. Yeah, that was pretty well done. You know what? I don't know if it already happened or not. Yeah, they already have it. Let's see. You know what? I think I'm gonna open DaVinci Resolve and drop the video in, just so we can analyze it frame by frame. So yeah, let's do this. My computer is having a really hard time doing all of these things. 22, yeah, 48, yeah. Oh well. Okay, so let me open the untitled project just so we can. See, edit. Let's see. Oh, this is really slow. Okay, now let's import video here. Okay, there it is. Then let's go to the very end. I'm not sure how to make that full screen. So it's nice to see that in reverse. The particles look awesome. Yeah, no, this is where we were moving. Let's see. Yeah, so that was a bit weird. Let's zoom in. Oops. How do I move this guy? Let's see. So we destroyed the 3 of them. And went down. I suppose we were right. I suppose, yeah, it's hard to tell what happened. But in this case where we hit the precise corner, we could have hit like this one first. Well, let's say this one and this one and this one. So we go up, to the left, and down. So yeah, I think that'll be it. Was that the weird one? Or was that a more weird one? I'm probably gonna have to watch some of these in slow motion. Or I could play the game in slow motion, but it would be kind of boring. Yeah, I think that was the weird one. And then I'm going to record. No, I think that was a more weird one. Yeah. A weird one. Yeah. Let's see. Yeah, see? It's the same thing. But I think we are wrong. Because in this case, it's evident that we hit this guy first. Then we should have hit this guy. I think our P is not considering the half size. Yeah, see, we should have hit this guy and then this guy. We should not have hit. See, we should have hit this and then gone up. But we hit like the 3 of them. And hit this guy and then went down and then hit like a lot of them. But our particle systems looks really cool, I think. So yeah, let's review our P's. You know what? I think I'm gonna draw. Yeah, let's do this. I'm gonna do like a V2 old ball piece. P, let's make 16. And then we do a V2 old ball F size 16. Then we're going to do like next old ball. Okay, and whenever we hit a block, whenever we hit a block, let's see. Yeah, we're not gonna get in this case. I'm gonna print in this case. And whenever we hit a block, I'm going to do the old ball P at next old ball equals, well, I really want to save this ball P. So this is like the collision point. Okay, and then the same thing for the half size. I'm going to do next old ball plus plus, and if the next old ball is greater than the raise size of the old ball P, I'm going to do the next ball P, next old ball equals, okay, and this would be the half size. And the half size actually floats. Okay. Now let's see the gameplay. Play movement here. Here I'm gonna go through. Oh, we do clean the screen, right? So clear green screen. Yeah, we're gonna do like 4. The old ball P. I'm gonna draw transparent rotated rect. Okay. I'm gonna draw at the old ball P I P. I'm gonna make the V2 old ball half size. And then I'm gonna do 0 for the angle. Let's do green. And then let's do point. P's not remember V2. Hi, glad you finally got you live. What are you doing? We are doing a huge change in the collision system, because the first time it's not V3. The first time we wrote the collision system, which was in the second day, we actually didn't know exactly how to structure it, and it was a crazy thing, right? But we learned a lot through making the game, and that's one of the huge advantages of, like, one of the huge things, I suppose, which is the more you make the game, the better you are at making not only games, but the game. So there were a couple of problems with the collision, and now we're doing a big change in the collision system. So just, and we already did a lot of code stuff today, like just changing the same things, stuff. What's the problem? The color. U2 pointer. Oh, it is a pointer. So we are almost done. We're just going to fix one collision problem that we still have, which probably has to do with the way we're calculating the P for the ball, the new P. Like, but the idea of the ball is that now when we do like big motions, we manage to get the ball to this point. I think it'll be correct though. And then we in the same frame, we continue doing the collision. So we may hit like these two guys in one frame, for instance, if the ball's pretty fast. So that's going to be really, really cool. And it's really better as of now, but still not 100%. Color. What's the problem? Oh man, these error messages should be a little bit more helpful. Like parameter 4, float to float pointer. Is this also a pointer? Render transparent. Yeah, this guy. So we take the size, the angle, the color. I don't know what happened. It's just a normal color. Can't convert from the V to pointer. Oh, okay. Yeah. So that was weird. I saw the pointer and I thought the color was gonna take a pointer because that's what we did in another function. Now whenever we hit a ball, we should stick there. And we do. Our little shadow. And I think, well, you know what? I think this is wrong. See how we are inside the ball? This other ball here? We should really be like, this. So in the level, let's change. Let's see the ball. Yeah, do ball collision test. In this case, the problem was the ball Y, correct? Yeah. You know what? We could play now in super slow motion. Okay, let's do that. Let's do that because I think now we'll be able to. We should be able to see if the ball is changing rapidly when we collide. Yeah, it's gonna be hard. Okay, but it's nice though. Okay, let's see. Yeah, I got it. Seen a couple last videos. It's included. Yeah, it is. Let's see. Oh, it was still hard to see, man. A couple things. The particles. I'm gonna remove the particle system. Render particles. I'm not gonna remove the render. I'm not going to. I'm not going to draw particles. Unreachable code. Yeah, thanks compiler. Very, very useful of you to say this. Buggy. Yeah, I do. It is. It wasn't completely buggy, but it was a little bit buggy. And now it's just a little bit buggy now. It's even less buggy. As I was saying, all you have to do is get that like a little bit better every stream. But now, since we are taking the time to improve that, it should be a lot better. Let's see. Okay, this looked correct. I'm gonna do one more just so we can. Yeah, I think the value is wrong. I'm going to stop the recording. I'm going to drop the video again on DaVinci Resolve so it can go frame by frame and analyze it. Let's see. Yeah. I don't know, man. How to move this guy? I'm not sure. Oh, because the ball grows. So our P is perfect, except the ball grows. So this causes weird problems. So I think I'm gonna move the ball to the direction it grew. Yeah. But Let's see the other one. Yeah, that was even worse. The center kind of looks correct, I think, but the increase in size doesn't. So yeah, let's go to the let's see, collision. If we collided, yeah, here. Okay, we increase the size, increase ball size. Let me just play a little bit with the decreased ball size. Well, not the decreased, but the non-increased ball size, just so we can make sure that we don't that we are better at the collision. It's gonna be hard to get that bug 100%. Dude, now the game's super fast because you played that in super slow motion. Just a quick note while I play the collision a little bit. Doing debug visualizers like the ones we just did, that was pretty quickly, that was pretty fast, is awesome. Because it took us almost no time, and it helped us like 1,000%. So that's always good, always good. What's that? Play sound variation? What's the next playing sound? What? The next playing sound is minus a huge number? Why? So we found a bug in our audio system now. Okay. Next playing sound. If it's we set that to immutable sound count. And well, I'm going to assert is well, less than or greater than or equal to 0, and it's less than or equal or less than the array count playing sounds. Okay, same thing here. Let's do the next playing sound. Oh, that's it. That was a weird bug. But I think we are perfect in the collision. But we do want to change the ball size. So we can't just comment this out. So we have to make the code work in this situation. What I want to do is I want to move the ball the amount it increased, right? Maybe in the increased ball size. Let's see. Increase. Nah, whatever. So we're gonna set like old size. It's gonna be ball F size. Okay, we have the old size and the new size. So yeah, we change the ball movement, whatever, and then we're gonna set the ball P. Okay, I'm gonna set that. I'm going to add that to the ball P plus. What do we want? We want to move that. If we collided Y, we're gonna move that twice the ball P in the Y. So I'm gonna make like a size offset. Okay. And if the ball P, if the ball DP, well, first of all, let's do this here before we update the axis, because then we cannot read. Yeah. Okay. Size offset, yeah. If we hit on the y-axis, if we are going up, the y-axis is positive, we have to move it down. So size offset dot y is going to be equal to the ball half size minus the old size times 2. I think that's correct. Okay, now if we are not moving up, I'm gonna do the same thing, but it's gonna be the negative. So the new half size should be larger, and then the minus half size. Okay, now same thing for the x. I'm gonna change the x, and but before I change, I'm going to test if it's greater than 0. So if we are going to the right, which means that we are increasing the x. This is wrong. If you are increasing the y, which means you are going up. Surely, yeah, that's wrong. Okay. Okay, now same thing for the x in this case. So, I don't know. I think this will work. Ball half size. Oh crap! It's ball arrow half size. Okay. Let's see. Do you guys think it's gonna work? Let's see. Okay, I think that's a lot better. Yeah. Yeah, dude, that was awesome. Yeah, so when we got the inside guy, we got a wrong collision. So that's 0 is because we were inside. So suppose that's the last case, right? That we should work on. And let me just if 0 this guy. And if, and I'm going to just for the sake of making it easier, I'm going to add that close. Okay, because if we ever want that back, which we are going to need it, I suppose. So, okay, so the last problem is when we are inside the block, I think we're going to do the thing that we were going to do and we didn't do, which was to see whether or not it was up or down based on the difference. Yeah, the sweep path. Yeah, I even started doing the code. So if, yeah, this is not 100% precise. But I think that'll work. Because this is supposed to be like in fast cases. So I don't know, I think this may just work. So I'm gonna update the axis, the y-axis. The y-axis is 1, right? So it's gonna be y. Do we have ternary operations in C? I think we do. We do. So I'm gonna do like if the ball py, if the sweep path py, and I'm gonna take the absolute of that. If this guy is greater then the X. Then I should do 1. Also going to do 0. P is not a member of V2. Missing semicolon before. Yeah. Okay, now we can assert is also a pretty good name. We can assert that the, well, I'm gonna put it down here. I think you're like else invalid code path. Okay. Now let's play around with this a little bit. We are going to have to play with the collision a lot, just to make sure that it's working. Yeah, see, that was perfect. We got a 0. Dude, that was really lucky of us. I got another 0. So I got a 0, which means that we got... Okay, so we crashed. Yeah, our audio is problematic. Well, good thing we put that assert in. Let's see. Our playing sound was 64. Oh, because we're not testing. This is wrong. We're testing. Here. We should. Yeah, this is like inverted. Yeah, our. Let's see. We could probably make more sounds now. I don't know if 128 is too many sounds, but just for the sake of it, let's test with 30. Oh, let's do like. Let's do 16. Oh, 16 is it's not gonna work because we have to have at least the number of sound in the beginning. So yeah, so this is problematic. I mean, we are supposed to test that later, but I don't know. So we're gonna test to get the free list. If we have sounds in the free list, we're gonna get from the free list. If we don't have the free list, I'm going to assert. This guy, and then I can pretty safely get from him. I'm gonna increment it, and then if it's greater than the array count, and set that to the immutable sound count. I can assert just to make sure, but yeah, that should fix it. Let's play another game mode. Let's see how the collision stands out. Maybe with the comet, it's gonna be a little bit crazy. Awesome. Got a ton of zeros, and it looks perfect, I think. Oops. Ah! Okay, I got a ton of power downs there. Dude, I think we can call it victory. See how they just scraped the blocks? That was pretty cool. I think we can call it victory for the collision for today. Awesome. Really awesome. Our collision is really, really cool now, I think. Oh crap. I was stuck between the TNT. Okay. So I think I can call that a victory for today. What do you guys think? That was great. That was great. Really, really liked it. Let me just remove that print. And let's clean up this guy. I don't think we're gonna need this guy anymore. If we do, we can write that again. That wasn't too hard. Gonna remove this guy. Now it's old code. Let's see if there's any if zeros here. Let's see in the levels. We do. Now this is gonna be old, so now we are way cleaner here. Way cleaner. Same thing here. Way cleaner. And let's see. Probably gonna remove this guy just so it's easier to read. So now our collision is way better, way better. And maybe I'm gonna inline this. I don't know. And just for a quick test, I'm gonna change the... I'm not going to sleep. Just so we know if our frame rate is good. Oh, we should also go back to the non-optimized build. So go to the optimized build, I should say. Well, it didn't link. Okay, so we got 1 and 2 milliseconds per frame. Now we're at 1. When we collide, we have a little bit of a hit when we hit a ton of them, because you have to calculate everything twice per frame. But we are great. Dude, that was crazy! That was completely crazy. Dude, I should probably finish this game just so I can enjoy that high score. Because that was a huge victory. Huge victory. Dude, I'm gonna have to clip that and post that on Twitter or something. Because sometimes I do have some crazy plays, and since we are playing at a higher frame rate, the trail looks way better. Maybe we're gonna do the lerp for the trail. I don't know. May not be 100% though, because we do have to lerp between the old position and inner position, but the old position may change. So. It's also to test the collision against like these smaller cases. But, oh crap. Okay, we still have 2 lives left. Awesome. Awesome again. Yeah, these final blocks are kind of hard. I don't know how it was in the older breakout, like the really old one. If you really had to be super accurate in the very end, but they had bigger blocks. But that's kind of the price we pay if we want to do like crazy stuff with the breakout gameplay. So I'll take that. By the way, game looks and feels awesome. It shows what we can do even without fancy engines. Yeah, that's the thing, man. And by understanding what makes these subtle things make the game really pop, like this crouching stretch and the audio, we still have to work on the values a little bit, I think. But then when we do make use of a game engine, which has a lot more tools, right? We're going to be able to create such a better game than just create like random particles in Unreal or something. Yeah, the particles look great in Unreal, but if you don't know how they can enhance the gameplay exactly, you're not going to reap the most benefits. So making a game with no engine really helps you to understand the priorities in making like, oh my god, it's gonna be hard. Like the animations or the particles, and like making the walls move like that was a great call. I really liked it. Let's see. Oh my god, it's gonna be hard. And we are going to add screenshake now. So it's nice of you to. Oh, it's nice of you to. Let's see. Oh my god. Maybe I'm gonna fail with one block missing. Okay, succeed. Huge high score. Victory. Okay. Open the window here. Awesome. So I say we should now be super happy because of our collision victory today. And now we should work on the more feel stuff. The screen shake. Oh, and the level transition. The level transition. Maybe we should do like the asset pack. Maybe we should do like let's see. Maybe we should do like the OGG reader and the asset cooker first. Yeah. Okay. Async OGG reader. Yeah. So that's the plan. But that's for next time. I think today we can still pretty much do. Let's see what time is it. Yeah, it's still a little bit too early. We can do at least the screen shake. It's gonna be not too hard. It's gonna be pretty fun. But I do need to take like a 2-minute break so I can get more water and go to the bathroom. So let's take a 2-minute break. And I suggest you also get some water because now we're going to improve the game feel. It's gonna be really cool. And then probably do the level transition. That's gonna be really nice because I haven't done that with no engine before. So, okay, kind of confessed, right? Like a cool animation before the game starts. Okay, let's do that together next time. So maybe you guys can help me. 2 minutes. Okay, I'm back. Now let's improve the game feel. That's gonna be really cool. Screen shake. I think that's not gonna be too hard, but you know, famous last words. I said that like 3 times in the series, and every time I said that, I spent like hours doing it. The problem in doing our screen shake is that we have a ton of different draw calls. So we have like, let's see, draw rect in pixels, draw rect to be transparent. Then we got draw rect, and let's see, we do the calculate aspect multiplier, but we don't have a camera, a notion of a camera. So I suppose that's the first thing I'm gonna have to add. It's gonna be quite easy to test though. So yeah, I'm going to do like a v2 cam p and v2 cam dp. Okay, and whenever we initialize the game, I'm gonna set the cam p to, let's say, 0, and the cam dp to 0. I mean, they should be 0 already. Okay. Okay. Now I think I'm gonna go through each one and change that. Yeah. So the drawing pixels, don't care about this. The pixels dp to world. Oh, it's gonna be cool because, oh, okay. Yeah. Where's our scale? Let's call that the cam scale. Yes, so now it's hard-coded. That's okay now, because it's called cam scale. Okay, scale down here. Oh my god, so many scales. Yeah, this we haven't improved still, because maybe we can improve that. I'm gonna write a note on the more optimizations. You can do like expand the yeah, I think I'm gonna do that. The preamble. Is that how we write that? Of the draw rotated rect. Scale, it's going to be cam scale. Let's just keep going, and that's it. Okay, now let's go one by one and subtracting the camera p. Okay, yeah, we have to subtract this, like the camera, let's say, the camera p is 1, we want the guy to be at -1. So if we move the camera right, we want them to move left. That's pretty easy. Now, let's say, so this, the first one, draw rect. So I'm going to do p equals sub pv2 p cam. But this is going to be like, we're going to have to do this like every time, right? Then we call drawing rect. Now, draw arena rect, same thing. Oh, but we have a couple other values. We have the p, but we have the, well, let's just test if our draw rect is offset correctly. So it should be 0, but should probably set like the cam p dot x to 1. Everything should be right. It's going to be too hard to see. Let's see. Okay. Pretty cool. and 10 was also not that much. Nice. Now those are the rects, which the text. Oh, but we have so much stuff that's hard coded. Well, yeah, the player P is gonna suffer because that's not. We're gonna have to think about that. But okay, so draw arena rects. P in the leftmost. It's gonna be the same thing, right? I have to subtract. So leftmost. Gonna subtract the camera P dot X. Same thing for the rightmost. And that's it. Half size Y. Let's make like, oh, that's like 50. Let's see. Let's see. Okay. Yeah, let's do like 15. Yeah, so the arena is not 100%. Draw arena rects. So we do like the X, Y is the PY. Oh, we don't. We shouldn't offset by the these guys. Just the P. Just the P. Yeah. Now I think. For some reason we are not drawing the leftmost correctly. So the top one looks correct. Just this one. Half size Y. Well, I don't know. I know it was supposed to be correct. Oh, it's correct, but yeah, I think. Oh, since we haven't structured the game to work like that, the player P is gonna be a little bit more problematic. The player P and the hard-coded collisions. Yeah. So first of all, we have to fix those. Yeah. But that's weird. I mean, the player P should be correct in this sense. I don't know. We're going all the way to this guy, but oh, okay, that was kind of stupid of me because we haven't done in everyone yet. I mean, this guy's probably wrong, but the player is not the problem yet. Okay, so that's okay. So draw number, we don't need to do that because we call draw rect. Draw F32 calls draw number. Draw transparent rotated rect, we have to do this with a P. Okay. I think this part I cannot remove. This part we optimized. And this part was the part that we could optimize further. Okay. So, yeah. Okay, let's see what else we have. Draw rotated rect. So yeah. Bitmap, draw bitmap, same thing. Draw rect subpixel, which was the one that we thought that was a mistake, and the text I think it's just gonna call it draw rect. Okay, let's see now. Okay, now we don't even see the player. Oh, it's correct, I suppose. Huh. Okay. Right. Yeah, everything is working except. Look at those particles there. Everything is working except the clear arena. Yeah, see? Oh, it didn't compile. Dude, this Visual Studio take a long time to finish the game. Okay, now it's okay. Now we're perfect. Now we have a camera. Now that we do have a camera, we should be able to add Screenshake, which is what we want to do. Maybe we're gonna do just Screenshake today, and then next time we're gonna do these guys. Maybe. Yeah, because we've been streaming for like 2.5 hours already. And the collision thing, man, the collision thing is hard. It takes a toll on your head. Okay. Now let's do the camera thing, like cam P. Right in the beginning of the loop. Right before play movement. Right? So let's say update cam. And the way we're gonna update the camera, well, we could just do like the basic thing of the cam P equals add v2. You can just add a add v2 of cam P, and then a multiplication of like cam dp and dt. This is like the very basic thing we did a couple of times already. So if we set like here in the beginning, I can do it in the very end here. If we set it like the cam dp to be 1 and the cam y to be, I don't know, negative 0.5, we should have a camera movement. And we do have. And it's kind of funny, see how the player moves super slowly, but the out rectangle doesn't? Because the player has subpixel accuracy and the other one doesn't. So yeah, we see the difference there. That's awesome. It's almost makes me want to add game modes where you play around with the camera. You know what? I'm gonna note that maybe Donkey Kong maybe should add like at one point I wanted to do a Super Mario, but then I dropped that. But maybe I'm gonna do that again. Pretty cool. Now I don't want to do this. what do I want to do? Do you guys have any idea what I want to do? Any ideas of how we're going to do the camera? The camera will be a spring, just like the rest of our springs. Right? So, same thing. We're going to have a DDP here. It's going to be, well, the DDP is going to be, okay, it's going to be some offset. I'm going to copy the values from the player, but then we can play around with that. Of the desired, which is 0, so 0, and the current, P, so just cam P. Okay. Okay, so that's yeah, that's the first factor. Then we're gonna add the factor to 0 the speed. So we're gonna add these two guys, and this one's gonna be the same thing, a multiplication of v2 0, 0, 0, and the cam dp. Oh, this is wrong. This is a multiplication of the subtraction of these guys. Yeah. Yeah, now we're talking. Now it's same thing. It's multiplication of a subtraction. This guy in the camera dp, and that's at like 20, which is the factor that we did for the other guy. And then we can finish the multiplication, finish the add. Okay? And now here we're gonna add this guy to this guy. And we're also going to add the DDP. So add this guy to the cam P. And at this point we're also going to add the DDP times the dt squared times 0.5, which is like the formula of the derivative. That's why it's called DDP. I almost said in Portuguese, por isso. That's why. That's why the DDP is called DDP, because it's the derivative. That's still a word I have to say a lot more. Derivative. So that's the formula to getting to this guy, to the p, from the DDP. So we have to multiply that by the square of the factor, which is dt, which is time, and half. So yeah, we're gonna multiply this guy. I'm gonna add this guy to this guy, and then we're gonna add. Is that correct? Add, yeah, like this. Now we should still have a stable camera, but now let's do a little bit of a cool thing. Now every time we press up, let's add a bit of a camera movement. Let's see what we do with the walls. For the wall collision, I suppose we just add, right? Oh, do wall hit effect. Yeah. Do wall hit effect. No. Where do we change? Oh yeah, we just set it to 30. So I think we're just going to set the cam P, just to test, DP, sorry, to, let's say, 10 minus 10. Just for fun, let's add F32 in range. Yeah. So every time we press up, we expect to see like a slap on the camera. That's really cool. I don't think we are going back to our 0 position. So. That was really cool though. Especially when I pressed that a lot, like this. That was pretty cool. Yeah. Oh, we're trying to roll back, but we're having a hard time. Dude, Screenshake is always fun. Always. I mean, maybe not the best call for the game, but it's fun nonetheless. At least for us to play around with. You know. Oh, because we're not updating the cam. Yeah, the cam DP. We're not updating that. Cam DP is just going to be the add v2. Yes, this thing here. But instead of multiplying that by the square, just do the dt. And we're going to multiply it here. What? Okay, that was a weird compiler bug. Whatever. Let's see. Okay. Now we're talking. Now we are talking! Dude, that was awesome! Yeah! Look at that screen shake. Let's pretend we already programmed it. Dude, the game's gonna be so much better, like so much better, like a million times better when we add the screen shake. I mean, how come we haven't done that before? But everything needs time, right? Everything needs time. So player, ball, collision, player collision with ball. If we collide, oh, probably gonna make a function of that. Let's do like shake screen. Maybe add screen shake. Shake screen is more fun, but add screen shake is more representative. Okay, and I'm thinking about whether or not we should add the screen shake or just set it. Maybe if it is going to be way too chaotic. It's not the best place to put in the levels, but I'm going to put them there anyways because that's where we put our utility stuff. So yeah, let's do like inline add inline void add screen shake, and there's a screen shake factor, and let's change 100 for factor. Okay, and let's try just setting. Yeah, let's do the add screen shake 100, same thing we had before. But let's just set. This is where I pressed a lot, just by setting, which is pretty cool, I think. And let me try adding. So add v2. Let's see how crazy this is gonna get. Yeah, I like setting better. Okay. Now we should be good to go. Now let's just add these add screen shake calls whenever we want to add screen shake. So player collision with ball. Player collision with ball. We already added a screen shake. Let's do ball collision with the walls. Maybe we can do like a little bit less. Okay. They reach the inner. Oh, I should also add a noise. If we, yeah, let's also add screen shake in this case. When we lose a life, we can add a little bit more. After all, we lost a life, right? Is that correct? Yeah. Now the indentation. Yeah, so this if, and this else. Yeah. So I'm gonna add like 150 if we lose a life, and if we don't, I'm gonna add like 75. I'm also going to add a sound because I think there's a sound missing. So play random sound with variation. Let's see. The sound is gonna be sound redirect sound. The variation, just do like 0.3. And I don't think I care about the swarms. Well, could be the ball P, yeah. Okay, let's go back to adding screenshakes. So, cannot convert F32 ball PX. Okay. Now, ball block collision. Whenever we hit a block, add screenshake. And I'm gonna put 100 in this case. Let's see. What? Why no screenshake? Why no screenshake? Did I mess something up here? Yeah, I did. This doesn't even make sense. Yeah. Okay. Yeah. Okay. Yeah. I don't think I'm gonna add in the player collision because the player collision is the good thing. Maybe just a tiny bit. Just a tiny bit. Yeah. When we get a comet, it's gonna be super all over the place, I think. Yeah. I think I'm gonna play around with the spring values as well. And our collision is awesome. Our collision is really, really cool, I think. I think it's 100% now. Dude. Yeah, I think it's pretty intense now, the screenshake. And the spring settings, we should probably play around with that. Okay, let's try space invaders. Maybe the wall is too strong, I think. Dude, it's crazy. Yeah. Look at that, man. Okay, so I think I'm gonna decrease. What did I do? I don't think I did anything. Okay. So I'm gonna decrease the wall screen shake maybe to 30. This one I can leave like 50. And when we hit a block, let's make like 60. But let's change the cam key. If we, let's say this guy is, if we decrease this guy, we should have a smoother screen shake. Yeah, see, that's not very intense. This is like the initial force of the spring, like how much goes to the other side. So, how much was it? Let's try and make 5,000 just to 1,000. Let's see. Yeah, so this is a very quick and unpredictable screen shake, which I think is pretty cool. And if you decrease this guy, the screen shake is going to last for longer. It's going to go like back and forth for more times. Yeah. Yeah, I think this is better. Yeah, way better. Yeah, the lose life. Lose life is awesome. I could really even put that screen shake on the lose life itself. So let's make that 200. Because I don't know, man, we lost life. And we can also make these guys even smaller, I think. And then hit a block, maybe 50. Let's see. Let's play Tetris. Oh, that's weird. When we lost a life, the Tetris game, the ball spawned inside the block. Okay, so we got a small bug. In this case, if we are not in the first ball movement, or have you seen talk about game juice? Absolutely, man. And when we first implemented the first small things about the game juice, like the animations and stuff, I even referenced that, showed that talk on stream, and we talked. Oh, I didn't compile, man. Yeah, that really sucks. I showed that talk on stream, and we discussed about what are the elements that we wanted to add in this game. But absolutely, it's a great talk. For anyone who don't know the talk that Heiko is talking about, it's called Juice It or Lose It. So, yeah. No, it's not it. Juice It or Lose It. Yeah, this talk. It's really cool, man. I mean, super over the top by the end, right? But it is pretty cool. It's great, actually. You should be able to know the exaggerated version in order to understand what consists of the game juice, so to speak. But we should be able to tone that down for our game. Yeah, that feels pretty solid, I think. Really like it. Okay, let's do the spacing videos. Should also probably center the text, man, as a polished thing in the menu. Okay, this may be it for today. This may be it. We have implemented a camera system and Screenshake with success. So I think next time I'm going to start out by doing the level transition. Then we're going to do this. This is going to be kind of hard because it's kind of finicky to get the player collision. Like when we move him, we have all sorts of problems. Then what happens if we move really fast? I don't know. It's not going to be super fun, I suppose. But it's going to be cool, I think. We can play around with this a lot. The level transition to the main menu and back. And we should also play around with textures a little bit more. I'm going to play that off stream just to get a little bit more ideas. But I think I liked that other idea as well. So. Oh, actually, we didn't solve the Tetris bug. This is the Tetris bug. Yeah. It has to do with the order that we are reading collision versus versus the order that we are checking doing the game over thing, right? Not the game over, the lose life. So whenever we lose life here, we lose a life. Let's see what we do here. Yeah, see that we if we died, we set the advanced level. If we don't, we reset everything. We can't reset everything here. We can't. So I'm gonna do like we're gonna do a variable like this is advanced level, and this is, I don't know, let's call that lose life at the end of frame. Great name, except it's not a great name. Yeah, and this we should probably not do this either. Now it's game over. We should just same thing, I'm gonna advance to the current level. Yeah. Yeah, okay. I'm gonna do like lose a life, and if insta-kill, or if you don't have life. Then we advance level, set the target, play the sound, set volume. Advance level, set the target, play the sound, set volume. Okay, now we're gonna set lose life at the end, and we're gonna just simulate the whole thing. And then at the end, here we're gonna do advance, let's see, advanced level. You can do like if lose life at the end, we lose life. You set lose life at the end false. And then we set the advance level We set that to false. Okay. Okay. Let's see if we fixed stuff. Dude, Pong's loud. No, oh, Pong's so awesome. I probably had a massive screen shake when Pong. Yeah, I'm gonna do this when Pong hits the level. So in the level, let's do simulate level. So whenever the enemy in Pong hits the arena, add screen shake, a massive one. Well, maybe even bigger one. I don't know. It's maybe too much. We get too excited when doing screen shakes and stuff. Dude! that was a bit too much. But I also am gonna only test this. Let's go back to like 150. I'm only going to test this if you're not already inside it. Let's see. Like is colliding with wall. And well, if is Pong is colliding with wall. If it is not colliding with the wall, set the screen shake. Set this guy to true. Same thing down here. And then we do like the else. We set that to false. Let's see. Let's see. Awesome. Awesome. So we should probably add a sound effect as well. What kind of sound effect do we have for when the enemy hits the wall? Let's see. Yeah, that was a cool ad hoc idea. Let's see. Bricks. I'm gonna add the player wall one, but I'm gonna make it way bassier. Do we have the player wall? Yeah, we do. Player wall sound. So we're gonna add screen shake, and we're gonna play sound with variation. Yeah. Player wall sound. Let's see if I remember. No, I don't remember the parameters. Variation. Let's say 0.15 f, and the source is gonna be the Pong enemy p.x. Okay, but we are also, let's see, playing sound. We are also going to set the sound speed multiplier. Let's decrease that by like 0.2. So it's gonna be really bass here. Let's hear it. Let's hear it. I need to turn your volume up. Yeah, it's too low also. Or like a fool. So I think I can make that even a little bit bassier. 5. I'm gonna do like set volume for the sound to be the sound target volume plus, I don't know, let's do +1. Let's try to make that really absurd. Let's see. Let's see. Let's hear it. Awesome. Like one. Ooh. Dude, the game's so much better with Screenshake. Oh man, that was crazy! Oh man, oh now I'm in trouble. Okay, there you go. Oh, one left. Let's finish him. Finish him. Oh, okay, there we go. Oh, let's see if we fix that bug. Oh, and we did! We did fix that bug by changing the order. Okay, awesome. Dude, today's awesome. Today, everything was awesome. I like when everything's awesome days. Okay, I think I'm gonna leave it for now. Oh, it's 3 hours, pretty much exactly. Thank you so much for watching. I hope you enjoyed today. If you want to download the source code for free, you can go to my itch.io page. Let me, which is dan.h.io. Okay, come here to this game, and just click download now. You can download every episode's source code separately if you want to just see the progress and watch as we build together. Just click download now. And you're welcome to give me a tip, but if you want to just download, you just click no thanks. Okay? And just also for people who didn't see that at the beginning of the stream, we also have a license. And the license is do what you want with it. So it's either in the public domain or you do whatever you want with it. So you can do whatever you want with it. I don't care. This is just because people asked, oh, what's the license? I was like, dude, what do you mean? This is like just for fun, man, for everybody to learn and have fun. I don't want people to have to be worrying about, oh, do I have to put like, what is it called? Attribution? No, I mean, if you want to, I'd appreciate it. Also appreciate the donation, but whatever. Do what you want to learn from it and have fun. And you can also download, you can also watch the whole thing from my YouTube channel, which is youtube.com/danzaydan. And you can watch from the very first episode all the way to where we are now. And dude, the game has come along really, really nicely. I say that pretty much every day now because I'm really happy with the way the game is looking and feeling and etc. I really, really like it. Really like it. Really like it. You can also watch my tutorial series. I have begun an actual tutorial series where I teach you how to create a game in C++ from scratch. I mean, started at beginners, but I think it's pretty cool because it's kind of fast-paced. Each chapter is going to be like 7 minutes and so on. And there's a theory behind it, like the game loop and the platform layer. Things that we see in this stream, I explain on the other one. And yeah, and then I do like the beginning of the programming. And I'm going to post new tutorials every week, hopefully. And let me know what you guys think about all this, right? And yeah, hopefully you enjoyed the stream as much as I did. Hopefully you learned a couple things as well. Today was great. We did a lot of cool stuff. And that's it. Thanks for watching, and I'll see you next time. Bye-bye.